All right, good morning, everyone. This is Lisa Harnish with Certification Partners. We're here today for our latest CIW webinar, Whatever Happened to Web 2.0. We're here today with Dr. James Stanger. Good morning, James. How are you today?
Fantastic, man. Doing fantastic. Welcome to you and welcome to everybody out there.
Okay. We have just begun the recording of our webinar. This recording will be saved and posted to our CIW website in a few days, along with the slide presentation that James is going to show you. All of our attendees are in listen-only mode. We have you muted to keep the background noise down to a minimum. If you have any questions, please use your questions tool in our GoToWebinar panel. I'll try to answer those if I can. If not, I'll hold those questions and make sure James tries to just address them before the end of the session. James, you ready to take it away?
I think I am. Let's see if this is actually going to forward here. Welcome, everybody. Glad to have you here. And greetings from Olympia, Washington, and from Phoenix, Arizona. And welcome to the world. Today's agenda, we're going to discuss why the term Web 2.0, worked before, but not so much now. We're going to talk about the Internet of Things. What a term, Lisa, huh? The Internet of Things, and what that's all about. The big deal about big data, how that applies to the Internet of Things, the state of the semantic web, a term that was come up with, I think, by Tim O'Reilly, the same guy that coined the term Web 2.0. A little bit about crowdsourcing, what that's looking like. We'll throw in a discussion of JSON and XML, how that all applies, and how CIW prepares you for the future. Now, about us, for those of you who don't know who we are, we're CIW. Certified Internet Web Professional. We focus on Internet technology certification. Skills-based, it's holistic. We provide courses and certification exams for career and college prep. We provide Internet skills, and we put people on a lifelong learning path, not a vendor's product treadmill. Back in the day, we used the term vendor neutral to talk about skills-based education. That's what we focus on. Skills as judged by industry, and we focus on competency and job role-based approaches to education. And that's why we're globally accepted over the years. And as a result, whether you are on an IT administrator, manager, executive trajectory in your career, or whether you're in school getting your high school degree, your associate's degree, your bachelor's, or what have you, CIW follows you along the way, offering you a lifelong career path. Just so you guys know who I am, I'm James Stanger, President and Chief Certification Architect of the company. Over the years, I've written lots of titles. I've done a lot of consulting in security, Internet, and social media. I've done a lot of work as an instructor as well, working in web and Internet technologies and social media. Well, let's get into the fun stuff with the presentation. Well, folks, how has Web 2.0 morphed? Well, first, let's talk about what the whole idea was. Now, back in the day, about 7, 8 years ago, I think it was, Lisa, Tim O'Reilly, the guy who owns a company called O'Reilly Publishing, who knew? And Tim coined a term really kind of flippantly. Just said, oh, yeah, it's Web 2.0. And that term kind of stuck for about 7 or 8 years, so much so that, for about 7 years, they ran a Web 2.0 conference. I think the last one they had was sometime last year, and pretty much announced, look, Web 2.0 is already here. There's no need to have a conference about something that's supposed to be new, which in fact has become internalized and is now everywhere. So let's talk just for a second about the characteristics of Web 2.0 that were proposed. Everybody remember when the idea of the collaborative web was a new idea and interactive. Now we have that with us. Facebook is here, okay? Been here a long time. But the idea, here are the key words and the key phrases that were used to describe what Web 2.0 was supposed to be and frankly has become. Collaborative, interactive, using lots of technologies, but especially open source technologies. For example, Google tends to use more Linux-based tools. Netflix does as well. All of these are examples of what Web 2.0 has done, whether it be Wikipedia and what have you. Users add value to projects. Users are not just consumers. They're actually co-developers now. The concept of the perpetual beta. Remember when the idea, if you were using a piece of software, you wanted to know exactly what version it was and where are we until we get from the 0.5 or the 0.75 to the 1.0, and then I'll buy the 1.0 version. Well, nowadays, we don't so much talk about that, about versions of software. We kind of do, but really, the idea is it's perpetually being fixed and perpetually being improved. So collaboration, cooperation, all of these things are very important. And then this last one is where you kind of move from Web 2.0 to kind of, I think, the next phase of Web 2.0, and the idea of being able to internalize the judgment of the crowd into software. In other words, the software itself can actually find some sort of way through clever programming, through algorithms, etc., to grab the wisdom of the crowd and then turn that into a product or turn that into something that can actually be used by the business. So there is a brief overview of the characteristics of Web 2.0 as proposed, 7, 8 years ago. And Tim O'Reilly, if you go up to O'Reilly.com, he put together what's a fairly classic little meme map of basically the types of technologies, the types of important concepts that are applied to Web 2.0. So I wanted to make sure that we defined our terms here a little bit, folks, before I went on and said, whatever happened to these things. But take a look at this little map here. Delicious no longer exists as a separate company. Got bought, by Yahoo, I think. But the idea of tagging data rather than organizing it. And it's because tagging does allow organization, but tagging allows the crowd then to come out and choose the data that is the most important and the best. The cream rises to the top, as it were. Page ranking, blogs. I'm looking at the top group of circles here. And then you have basically examples such as that existed, and many still do, Google, with AdSense, Wikipedia, etc. But notice the pinkish circles, the idea of what Web 2.0 is supposed to be about, data as the intel inside, and I'll be talking about that shortly. These are generally the concepts that are important in regards to what Web 2.0 was as proposed. And the core competencies has to do with services rather than packaged software. And again, we all think to ourselves, well, yeah, we're already there, James, and that's the point. In many ways, we're already there because the term software as a service is now so common, we don't even use the term. The practice is so common. And we've moved largely away from packaged software. Adobe really doesn't package software anymore. It's all downloaded, and it's available through the browser. And the software that's happening now, for most people anyway, is through the phone rather than something that is just on a desktop. And by the way, this little Web 2.0 meme map, you'll notice, doesn't really take into consideration mobile. Right? That's one of the major changes that's happened and one of the major evolutions. So why is the word Web 2.0, why does it work and not now? Well, there's this thing called the technology adoption scale. There's a guy named Everett Rogers came up with this life cycle. And he basically said, look, any piece of software or any particular movement, whether it be Web 2.0 or cloud computing or big data, name the cool or happening kind of technology or approach. And there are early adopters, and then there's the majority of adopters, or the early, and then it goes into the late majority of adopters, and then the laggards. Okay, so there is a curve here. And so you have the early adopters who tend to be visionary. There tends to be lots of waste in terms of wasted time. The software doesn't work like expected, but you like to be on the cutting edge. The reason why early adopters do what they want to do is they tend to look for an advantage. Okay. Now, when it comes to Web 2.0, okay, people wanted to adopt it because they wanted to use crowdsourcing as an advantage. The creators of Wikipedia, for example, said, we can do better than Encyclopedia Britannica or whatever. We want to use the crowd as an advantage because a group of really smart people may not be able to compete with Encyclopedia Britannica. But if you can somehow sift through and grab the wisdom of the crowd, you can create something like Wikipedia that I know is very controversial, right? I mean, but it's still a very interesting environment, a phenomenon that's happened. And there are many other examples here we'll get to in a second. The middle adopters, they tend to wait until it's safe and they follow trends. Okay, they don't set them, or they don't really want to get a little ahead of the curve, as it were. They just follow it. And then the late adopters, some of them just don't get it. Sometimes they're invested in old ways, and for good reason. That's fine too. The reason I bring this up is that the Internet tends to internalize technologies or internalize terms, such as Web 2.0, as they become adopted. So I wanted to talk about this technology adoption curve and note that Web 2.0 was an early adoption term. And by the time the curve got up to the top there, you know, where it was safe to talk about these things, it no longer really is particularly valid. But so it's all here with us today. And this next slide is designed to show you folks that we've adopted these things already. Open source 10 years ago was something like open what? And Google, of course, was doing its thing, just getting started. Facebook, barely even around, if at all. You know, college idea. But now, you know, it's part of what we do. And I don't know what you folks use in terms of Pandora, or if you use iHeartRadio or other things like that. But LinkedIn, learning platforms, all of these things are with us. And we pretty much know how they work, don't we? So I want to just wanted to talk about this really quick and basically say Web 2.0, of course, hasn't gone anywhere. It's simply a part of what we do. We've internalized it. So what's the future of Web 2.0? Well, you know, I don't think there's going to be a, you know, Web 3.0. Again, it was just a marketing term, really, or a quip. So there's really not going to be a 3.0. But the future of any worker in the web is to focus on these types of skills, harnessing the power of collective intelligence. And ask yourself, in what you teach or in what you do, in what way are the daily activities, the weekly, the monthly activities that you do, how do they help harness the power of the collective? And by the collective, I'm not talking about the Borg necessarily. I'm talking about your audience, your customers, as it were, or the people that you work with. In what way are you using technology to harness that so that it's not lost in the ether? Let me see if I can explain a bit more. Remember the Intel Inside campaign? And it was every time you bought a computer, a lot of times when you bought a computer, it had Intel inside the computer. So instead of buying this box, it actually had, oh, look at that, there's an Intel processor in there. Well, you know, nowadays it's about intelligence inside, not so much in the box, but inside the data that companies grab. Because the future of Web 2.0 is all about grabbing data and then making sense of it. And I know that's a really simple way to talk about it, and that's the 100,000-foot view, whatever. But it's all about grabbing that data and then finding patterns and finding ways to understand what that data means. See if I can give a point. As an instructor, for example, let's say you're a high school, college, community college instructor. Imagine if we could grab intelligence from internal company conversations or instructor-led conversations with students. And I mean conversations, either vocal, you know, spoken. There is a lot, or written, or the things that are communicated in one way or the other. Imagine how much of that is lost. You know, certainly, at least in today's world, as you engage with students and talk to them, I would imagine most of the things that you say probably are lost in the ether. But imagine if they could be recorded, some sort of surveillance thing, right? And all those comments could be recorded. And imagine if they could be sifted through, recorded, stored, sifted through. Imagine some of the things that we could learn. You could say, well, gosh, that, you know, could be a little scary at times, maybe so. But imagine, given a very, what do you want to say, positive view of what it means to capture, to store, and then process data. Imagine the things that you could learn from those conversations. Instructor to instructor conversations, seemingly unrelated discussions. Imagine if you could gather all of that data and then find a way to store it and then process it. Imagine that conversation is no longer really a Web 2.0 conversation, or this idea is really no longer that. It's pretty much all about grabbing huge amounts of big data, right, and structuring and trying to capture what things are. And this is what the Internet of Things is, folks. It's basically all of the things that you can attach to the Internet. Okay, so let's talk for a second about the Internet of Things. And, you know, this is one way in which Web 2.0 has morphed, okay? The Internet of what? I mean, you know, things. First time I heard that term, I kind of had to blink a couple of times to see if I had read it correctly. because it just didn't make a whole lot of sense to me. But I think it makes a lot of sense now. Things, the Internet of Things, as in structured or semi-structured or unstructured data. So the things that are on the Internet, that were on the Internet back in the day, were what? Hosts, right? Network hosts, a desktop, a laptop, okay? Protocols, you know, TCP, IP, all that stuff. HTML pages, web pages, images, and some video. Am I missing anything? That traditionally, the things on the Internet were that. A few hosts, right? Or, you know, a few million hosts, right? A lot of protocols being out there, right? HTML, images, and some video. Then, with voice over IP 10, 15 years ago, came the idea, you know what, we can put voice over the Internet as well. But now, we can put anything on the Internet. We have data on a massive scale as a result of all the things that we put on the Internet. Now, you can think to yourself, okay, so James, you've talked about voice over IP, desktops, laptops, mobile phones. Okay, we'll bring in mobile phones. But think of the other things that we attach to the Internet. They're now talking about, I just read an article about an egg timer that actually connects to the Internet. Refrigerators, cars. What does not connect to the Internet or what cannot connect to the Internet is more of a question. As a result, data on a massive scale will be generated because we're connecting various types of really pretty much anything to the Internet. Where if somebody had said 10 years ago that the glasses you wear will be connected to the Internet, it'd be like, yeah, whatever. Well, Google Glass, right, is an example of glasses, you know, things you wear, wearable technologies being connected to the Internet. So I think you get the idea. Now, clear back in 1998, when the idea of Google Glass was somebody's, dream or not, Merrill Lynch stated that about 80 to 90% of usable business data is in unstructured form. And I'll get into a second what unstructured data is. It basically means data that's kind of flying out in the ether and has no real structure or no real database associated with it. How do you take control of that data? Well, first of all, you have to capture the data from things, and then you add structure to it. But if you notice, there's an infographic here that I grabbed, and there's I have a source for this. Our connected life by 2020, you got about 24 billion connected devices. In 2011, there are about 9 billion total. There's enormous revenue opportunity that people are seeing as people connect to the Internet. And they see enormous opportunity for revenue because they can, if we can find out what people want and what they were doing, we can then anticipate marketing campaigns. We can anticipate sales campaigns. We can anticipate products that will make Don Amos's life or Lisa Harnish's life better, okay? Make it more interesting. So there's a huge revenue opportunity, and this is where people are seeing that they can mine through this data. So the things that you can attach, okay, so it's not just computers and tablets and phones, cars, kitchen appliances, alarm clocks, cameras, the things that you use to live with, the things that you produce with, tractors, equipment used, for example, if you're a farmer. I couldn't help but think of farmers, for example, because I went across Eastern Oregon here not too long ago and noticed I wasn't able to get into them, but I noticed that they were all using Wi-Fi to control each of all the farming equipment that was out there. I thought that was an interesting combination of agrarian 19th, 20th century thinking and 21st century thinking. But the things that you use to move around, GPSs, trains, all of these things become connected objects. And think of the data that can be extrapolated. Think of the data that can be interpreted, that can be derived from all of these things. So some more stats. In 2008, the number of connected objects exceeded the world's population. That was a while back. By 2020, 50, 60 billion connected things. That's just an estimate. By mid-2011, 20 typical households generated more Internet traffic than the entire Internet did by 2008. I found that in a couple of completely independent resources, so I thought I could get away with that quote, that idea. It's an interesting idea, that the massive amounts of data that are going on. The Internet has become a platform of devices and also software. And there are privacy implications on this. We've seen this with the NSA, haven't we, and what Google does and others. Do we have control about the things that connect to the Internet? When analytics are truly automated, what does it mean that people can take the data that we seem to generate in an unstructured way, through our alarm clocks and moving around a GPS in our mobile phones. What can people find out about this? And what does it mean about the conclusions people draw about us? Well, so what can you do with these things? Back in the day, we were just excited to connect them. You realize that, right? I remember it. It's like, we can connect them. You're home to the internet. Wow. Well, you communicate and share data with them. You update products, provide information, and do things. But mainly, you learn from them. So the Internet of Things is really the Internet of data, or the data of things. That's a very important concept to understand here, is that you can learn from things. And that's what Google does. That's what Facebook does. That's what the NSA does. A lot of controversy about that this summer in the United States and elsewhere. So that's something very much to think about. So the Internet of Things is all about grabbing data. So the big deal about big data, folks, is this. I think all of us have been, on one level or the other, the victims of too much information. Okay? So when it comes to big data, TMI is an even worse issue. Okay? The NSA and too much data. In other words, how do you store all that? How do you use it? How do you find patterns in the data? I think all of us can gather data, right? But it's a question of turning that data into actionable information, to turn it into wisdom. How do you go about doing that? When you have millions of terabytes, billions of terabytes of information flying around, how do you find a way to sift through that data so that you can find usable patterns? Okay? And that's the big point. Okay? So here's an example. This image here that you're seeing here, notice where it says current efforts - Google, right? This is a screenshot that was taken from basically an NSA or a government employee. And if you look at this little screenshot that's to the right of this, you'll notice it says public internet, Google Cloud, right? And then it has under public internet there's a cloud, and then under Google Cloud there's another cloud. And notice in the middle where it says SSL added and removed here with a little smiley face, right? This is basically outlining, on a bar napkin, as it were, what it means for the NSA or for the government to come in and say, well, people think that they're encrypting their stuff, and they are, but we can decrypt it, okay? And that smiley face is what set off a lot of Google's types. They didn't like the idea that they were being that they were being hacked, as it were, or that somebody was reading their data. Here's my point. This is the NSA basically doing big data. Okay, the smiley face is where they unencrypt data and then they grab it. And nobody really has a good idea. I couldn't come up with a good figure. There are a lot of estimates. But how much data is out there? Well, according to one pretty good source, you have 1.826 petabytes. Okay, or what is that? 1,826,000 terabytes. Okay, that's a lot of information. That's information that they were basically able to not just grab. They were able to grab much more of that, but they were able to tag that petabyte number. And then they were able to process about 29,000 terabytes. This is daily. And so they reviewed about 7 terabytes of data that they found interesting there. This applied example, I'm not trying to show how governments are good or bad here. I'm trying to show how they grab data and then they're able to sift it. So they can grab a certain amount of data, then they can process and actually start looking at it and then carefully review this type of data. And I got this from thewire.com. My point is this is really a classic example of the idea of big data, where you can grab information. So let me come up with some other examples. CardioDX is a company, I think, based in the Bay Area in the United States. They did a coronary test to try to discover heart disease. And using crowdsourcing, using big data, they were able to identify 23 predictive genes that could show that somebody has heart disease. Does anybody remember the BP oil disaster, the horrible thing that went down in the Gulf a couple of years ago, a while back? Well, there was a lot of information about the size of this disaster, how much oil and that sort of thing. Using big data, they were able to get actionable intelligence by taking a look at all the uncertain data, analyzing it, and then coming to a certain kind of certainty saying, well, this looks like the amount of the size of the disaster. Remember the WikiLeaks scandal, okay, the WikiLeaks scandal, where a lot of information was given out about information about Afghanistan, for example, mostly. It was a military leak. Well, by analyzing terabytes of data, a PhD student, discovered and analyzed troop movement patterns by analyzing the creation of the data. So they didn't go in there and really analyze all of those documents. It was basically analyzing the generation of the documents, and from that was able to extrapolate or able to derive information about troop movement patterns. And basically people were better able to understand exactly the nature of attacks around Afghanistan. So he sorted the flow of information from sources and was able to capture that information. These are examples, okay, of how they can take structured and unstructured data and mess around with it. So it's the job of big data to provide structured data. What is unstructured content, unstructured data? Well, there's one definition out there that basically says, look, anything that's not in a database is unstructured. And that's fine. That's okay as an idea. But basically, unstructured data can take the form of email messages that are running around a company. Okay, Lisa and I work for a company of about 40, 50 people, and imagine all those email messages, just the email messages, right? How can those be captured and gathered, and then how can you determine patterns to understand how the company works and to analyze the company so that maybe you can improve operations a bit? That's kind of what big data would do. You grab the PowerPoint slides, the videos, all of the voice conversations, the media files. All of these things are examples of unstructured content. Usually, unstructured content is text-heavy, and I'm going to qualify that. And I've used that term. I didn't just come up with that term. I did some research, and they'll say unstructured data tends to be text-heavy. I think it tends to be text-heavy, yes, but unstructured data can also be voice. Okay, voice. It can be vocal. So it tends to be word-heavy. I would use the term word rather than text there, because it's not just HTML files or even PowerPoint slides. Okay, it's words. And they don't have a predefined data model. In other words, there's nothing that describes the words and provides a context. That's the problem. If you have a lot of data running around and no context, you basically have really a lot of nothing, a lot of noise. Okay? But the idea is that if you can take that unstructured data and sift through it and find patterns, then it becomes usable data. So if you take that, you make it and are able to derive actionable data. So big data, first time I ever heard about it, I focused right away on the storage side of it. Wow, they can store a lot of data. But that's not really the point of big data. We can store data. We can store all sorts of things. It's a question of actually using it. So let's talk about organization here and see if I can explain what it means to create and find patterns and to create data about data, which is what metadata means. What does it mean to organize data? Okay. So I think we've all heard, haven't you, Lisa, the question, well, okay, the chemicals in the human body, how much are they worth today, right? If you were to take the average human body and distill it down or whatever you would do to find the cash value of chemical components. From the research I did, I found a few outliers who said, oh, about $1,000 of chemicals and things like that, down to about $1. But most people seem to think between $1 and $10 for the chemicals that are found in the body, okay? So if you look on the right here, I've got at least according to a few sources, the amount of, as it were, elements in the human body, from oxygen to calcium, phosphorus, potassium, all the stuff that's in our bodies running around doing what they do in our body, right? So it's worth about $1, right? Well, what if you were to organize those things into the constituent elements of the body, right? Blood, lymph, stem cells, body parts, organs, right? Well, I'm telling you, folks, a kidney is worth a lot more than $1, okay, or $10, right, out on the, I won't say open market, but whatever market there is. Liver, lungs. My point is, the more you organize the body, right, the more it's worth. And the same thing is with data. The more you organize it. So the question becomes, okay, we got big data, James, I get it. There are ways in which using web servers, traditional ones like Hadoop and the R programming language, that's another example. Those are examples of big data ways that you can grab data and organize it. Well, so the semantic web is supposed to be one of the ways in which we can improve on data. And it's an extension of the web. This is an official discussion from the semanticweb.org. The semantic web is an extension of the World Wide Web that enables people to share content beyond boundaries of applications and websites. Okay, what does that really mean? It means that if we create, as web developers or web designers, a page, how can that content be used outside of a person's web browser? Now, one of the more obvious examples is, well, spiders will come along, right? Google spiders will come along and grab that data and then process it and stick it into their databases where they do a lot of analysis of it. And hence you have search engine results that get, how do you want to say it, privileged over the other, okay, SEO, that sort of thing. That's an obvious example of how you have the web, right, and a spider comes along and shares the content beyond the boundary of an application. It's not just a web browser now. You have spiders. Well, how can we do this in regards to the Internet? How can we take the data that we create on our videos or on our phones or what have you and make it so that as developers we can organize the data and provide context in each document so that as data is sifted and grabbed from our web pages, from what we create, how can we help things provide a structure so that the information that we create and the way in which consumers consume that web page can actually be turned into actionable data? So there are actual technologies that are used out there, and that's called the semantic web. And these technologies can provide organization and context and structure. And so Web 2.0, or its successor, right, has found ways to add instant structure to massive amounts of data. And because it's all about the state of data. And by state, I mean this. Back in the day, we used cookies to take a stateless environment, a web page, and to give it a certain amount of state. The protocols used, HTTP, can remain more persistent. You can also make a web browser, instead of just a one-time transactional thing that kind of forgets itself each time you visit a website, a cookie made it possible that the web browser could start acting like an actual application where one session is connected to the next and to the next and the next. That way you have multiple sessions being connected to each other so that now the end user enjoys passwords that are remembered, and the company remembers whether that the user was here a couple of days ago, has visited other websites, and has now come back and visited our website. Now you can start drawing data here. So state of data means providing context. So it's kind of a mining metaphor. I think we've all know about how strip miners go along and can strip mine an entire mountain or whatever. I'm not trying to talk about the environmental problems or whatever here, but they can do this because they have equipment that allows them to efficiently take that mountain apart and find the good stuff in there, okay? That wasn't possible 100 years ago. It is now. Similarly, we can mine through data and add structure to it and find the good stuff in it. The Nielsen ratings people have been doing this for years. Google, in fact, probably not stole, but they were inspired by that, and so they were able to do it. The NSA, of course, is able to do it. So as we structure data, we find either an implicit structure or we use data mining and text analytics and what are called noisy text analytics to go in and see if we can apply a structure. And so there are a couple of ways you can do it. First of all, so you've got XML, HTML, and HTML5. All of these languages, the reason that the major reason why there have been changes to HTML over the years is because we've needed to structure data. That's why it's there. So HTML5 is cool as it is, as much as it has the ability to provide browser native tools, video, for example, much more efficient. We've had webcasts on this. It's also something that is an extension of being able to structure data properly. And that's the reason why XHTML was created, and HTML5 has not forgotten that. But there are other languages, XML, right, and OWL, right? And these are languages that are used to structure content and for sharing data, so that once you create a page, it can be used in many different ways. Another language that is, or use of a language that's come out, been around a while, but it's really become popular now, is called the JavaScript Object Notation language, JSON. And it's an example of a technology that can tag data and you can apply it to your pages so that the data can be shared across multiple platforms and multiple applications. It also makes it possible for you to tag data so that as people go through your web pages or people go through your products, those tags will capture data, and you can capture very, very important information. Querying results, and then the string is Lance Armstrong, and then the the JSON object then says from user to user ID. Basically, what you have is a tree that's being set up here, and the idea being that as you organize data in this way using JavaScript, you have a way of making it possible that as people come and grab your web pages and look at them and view them, you can then grab this data about that user's experience and derive tremendous amounts of information from it. Give you an example. We're working with a partner right now, basically to provide tagging information using JSON that will basically make it possible through our LMS to see how well students are using data, how well students are using resources, courseware resources. This is important because it allows us to understand how well students are consuming resources, how well are they really using resources efficiently. And this is very important because it helps us understand, are people really using the products the way they should? Can we make changes to the products? So JSON is an example of taking all of this big data, right, as people go through a particular CIW course, and it can generate tremendous amounts of information that we can then derive information. So we can structure the data that students generate so that as students come up to the LMSN with their IP addresses and their web browsers and how long they spend in a resource, we can structure this data and turn it into intelligence and information. And we can create entire ontologies so that we understand exactly how information works. And so we can make decisions and targeted marketing and relationship marketing. Targeted marketing means that you can go in using information and we can say to ourselves, you know what? We can go to a specific market because we know from big data that by creating a data model and understanding how our consumers are reading our pages, that we can go after a particular market and do better there. We can also do relationship marketing, and relationship marketing isn't about getting new clients or new customers. It's about taking existing customers and making them happier. And of course, you can also share data between platforms and applications. So this is where Web 2.0 has gone, okay, folks, from mere conceptual ideas that frankly have changed. Mobile apps have come in, and we've basically figured out ways to share data in a much more fancy way. Let's talk about crowdsourcing a little bit, folks. How is it used today in 2013? Did a bit of research and found out that the top applications of crowdsourcing seem to be in e-commerce, advertising and PR, various technologies in the technology sector, and in finance. Okay, and those are the big four, it seems to be. And e-commerce, when I took a look into that and delved into that a bit more, I was kind of surprised about what they called e-commerce. The primary examples included Netflix, okay, but of course Amazon. Netflix kind of surprised me because I would have expected a fifth little bucket, and the fifth bucket I would have thought would have been something like entertainment, okay, or streaming or something along those lines. But those are the top applications, and also kind of took a look at who does the crowdsourcing in these sectors. In other words, what are the titles of the people who do this stuff? And the terms used out there were data specialist, sales support specialist, digital media analyst, and even the term data steward, which I don't get that one. I mean, I get it, but it seems kind of an odd term. But a data specialist. These are kind of the, right now anyway, the job descriptions of the future. When I say of the future, of 2014, and those terms, skills will morph. The skills will morph, of course, but those terms, the job descriptions will morph. But a data specialist is somebody who has the ability, using HTML, XML, JavaScript, right, JSON, right, even the OWL programming language, all of these things to be able to grab data and use it properly and to understand it. So as an individual, what is your foundation, and I use that term advisedly, what is your foundation of technology that allows you to understand what a data specialist does, what a sales support specialist does? Of course, we in CIW Foundations do talk about these types of technologies very extensively. But this is where crowdsourcing is in 2013. And so crowdsourcing tends to be used in the following ways. Crowdfunding has been a big thing over the last couple of years. We've all seen it being used really well. Some people have been quite successful. I think there was an example of, what was it? I want to say she was a page. I think she was in Washington, D.C. in the United States. She was the term I'm searching for, but an aide, basically, an unpaid voluntary aide. And she wanted to keep working for a particular politician who just traditionally, they don't pay for those things. And she still wanted to do it, but she just needed the money. And so she actually went out to, I think it was GoFundMe, it may have been Kickstarter. These are examples of websites you can go to, and to do crowdfunding. The idea being that if somebody kicks in 75 cents or $75, doesn't matter what the figure is, it could even be a penny. If you get enough people to catch the vision of what you're doing, you can fund projects. And there has been quite a movement towards crowdfunding, that when people do it right, they can really get a great thing going. That's a good things going in terms of funding. I'm waiting for the Twitters, the Facebooks of the world to do something in the crowdfunding space. Most people tend to see this as small potatoes. In other words, if Lisa and James have an idea, they'll do it. Okay, they'll use something like this. But I think you're going to see larger companies doing something like this. So product improvement is another major way in which this is done. We can, using Threadless, which is a T-shirt company, okay, they have done a great job of going out there and finding ways to make T-shirts more interesting, okay. Netflix recently has created a new interface. They didn't create that interface just because they got a bunch of smart people together and created an interface. They took information and data from what users were doing on various platforms, PS3s, mobile devices, and traditional computers, and to create an interface that works better. So these are all examples of the types of ways in which crowdsourcing is used. So I gave a bit of an update, folks, about how crowdsourcing has worked these days in 2013. I've also put together some resources about what big data is, about how the semantic web works, about JSON, and again, everybody's going to get a chance to download this information, download this here in a couple of days so that you can grab the PDF here. And so there are additional resources I put together about crowdsourcing, about the Gartner Hype Cycle, what the NSA is doing here. So right now I'd like to see if I could answer any questions people have about what we've been talking about in terms of big data, about where Web 2.0 went. And so here's a summary of the things that we've talked about just as people are putting together their ideas about what they want to ask. We talked about why the term Web 2.0 worked before, but not so much now. We talked about the Internet of Things, the semantic web, little report about crowdsourcing, and of course we talked about big data. So does anybody have any particular questions? And I want to talk about this slide here too, if not too many questions are forthcoming. So Lisa, how are we doing on questions?
It's actually been pretty quiet. We've had a couple of technical issues with some audio issues, but there hasn't really been any questions about your presentation so far. I guess you're just doing a really fabulous job, James.
That I'm just boring people to death. Although I still see people are still signing in, so are still around. So, well, if there aren't any particular questions, let me go on to this particular slide here, folks. This slide here, we're going to be doing webinars throughout the next year. Certification Partners is, and for CIW, and we've put together a few ideas. Okay, and this is basically my attempt to do a little bit of crowdsourcing. Some of the ideas are about anonymization and privacy and ethics in the 21st century. Some of you may have heard of the Tor network and NSA. What does Tor have to do with anything? I'll bet you $5, by the way, Tor was named after the Ghostbusters monster. But anyway, okay, so anonymizing. What does it mean to anonymize yourself? And we could do a webinar about the Tor network and about various ways that you can anonymize yourself. What about social media crowdsourcing, SEO, and analytics? And a report about how, an in-depth report about how they're used. We also talked about the new power user, what it means to move beyond digital literacy. And with number 3, for example, I think today, folks, we have an increasingly sophisticated websites out there that you have to use in order to get by. And I'm not talking about just going to Netflix and watching a video or going to Amazon or whatever. I'm talking about websites about healthcare, okay, that you have to manage your healthcare from a website, your banking. I think a lot of these increasingly sophisticated websites out there, folks, are so sophisticated that the average user, now I'm not talking about necessarily the 80 to 90 of us on this call. I'm talking about the average user out there can't use it properly. So what does it mean to become a true power user so that you can use a 21st century website? So there's a topic there. User interface design tips, tricks, and traps, and then creating mobile apps. I'd like to hear from you folks about topics that you would like to see. So you can email them to jstanger@certification-partners.com or to ciwcustservice@ciwcertified.com. These are ways that you can go ahead, or you can certainly enter them into the chat window, and we'd be happy to take that information from you folks. So, yeah, by the way, so any topics that you have, Alan Collar has a great point. Web 2.0 has kind of gone the way of artificial intelligence, right? Once we achieve a certain level of a goal down the road, right, that's good. It becomes common, so we need to look further down the road. That's good. Brian has a question here. Do you think that the Internet will be accessed by virtualizing yourself? I don't know about the virtualizing yourself as a person, but we are all becoming more virtual all the time. For example, I taught a class in security here at the beginning of the year, and using an environment that was basically like Second Life. It was a virtual environment using avatars. And interestingly enough, I think I know I was able to capture people's attention far longer as a fake person than as a real person. I have to say that was a bit of a blow to the ego, Lisa, but at least I survived it. But yes, I do think that the idea of virtualizing yourself will be increasingly important, not so much just to capture people's attention, but to basically create a persona that is useful in a particular context. So it's almost like a smart schizophrenia that needs to happen in regards to virtualization. You're still one person, okay, at least, gosh, I hope we all are, but you are going to be able to present and have to present yourself in a radically market different way through virtual technologies. So it's all about identities, isn't it? Yeah. There was somebody who missed the beginning of the presentation about how it's not, Web 2.0 is not a useful concept. I think the concepts in Web 2.0 have become so internalized now in other technologies, from Dropbox to LinkedIn to what have you, that I think the term itself is no longer as useful as understanding other terms, such as crowdsourcing, such as big data, and even big data itself has gone that way, right? We're simply talking about ways to process data now and share data. Mm-hmm. There's a question here about Dropbox is attempting to monetize. Yeah, how does this affect our privacy? That's a great question. I do have to say it's funny that the folks at Google really got their hackles up about how the NSA was hacking them, because they didn't like the idea of the NSA doing what they're doing. And I'm not trying to say I'm on either side. I'm just reporting. But I do find this interesting. Google has been doing much the same thing, guys. Funny. It's okay if Lisa does it, right, Lisa? But it's not okay if I do it, right? Or vice versa. I do find that really interesting. Yeah, because, as far as I'm concerned, you don't know what you're doing. That's kind of the attitude that they're both taking with each other. That's right, man. That's right. Or we know exactly what you're doing, Lisa, and I don't like it because it's it's not right. It's not open. It's evil, and Google is not evil, right? Well, you're right. So let's talk about Dropbox, right? So as they're attempting to monetize, right, it could very much affect privacy because as a company monetizes, as you put it, as they go public, right, control will go away from the actual company and towards shareholders, towards the board, right? And of course Dropbox, because it involves storage, the idea of privacy and storage, so you have two major issues here. As a company changes its MO, as it were, its stance, right? Yeah, there are a lot more people that they have to answer to, and so Dropbox could very much, like any company, change radically as they go public. The other issue, though, is kind of innate to the technology of Dropbox, storage. A lot of people really have an issue there. I think we got, is it Shumei? Is interested in Shumai, sorry about that, Shumai, numbers 2 and 3. So we can go ahead and put that down. We'll sift through that and we'll derive the information there. So there you go. Chris is interested in 4 and 5. So we'll have to get Chris and Shumai together, see if they can battle it out. A question here: is there an education process or education program where one can learn about gathering and using big data rather than reading individual reports, blogs, and websites? Great question. We have a big data course in our roadmap. It does not exist in time and space yet, but it's something that we have put together and have proposed. It's something that we're looking to develop starting at the end of the 2014 year. But yeah, there's a need for that, isn't there? So great question. Great question. Those seem to be the questions that I've seen here. Oh no, there's just too many questions, Lisa.
Sorry.
Here's one. An IT professional made the statement in a conversation yesterday that the web, like many other technical advances, is a hot item right now, and it will eventually phase out and be replaced in the coming future. Would you agree with the potential project, or what thoughts do you have about it? Well, wow. Okay, here's the funny thing about the web is this. The web is going to I've seen the web going to be replaced by several things. So let me see if I can go way back. Lisa, do you remember Gopher? Before the web existed, there was this thing called Gopher. It no longer exists, really. It went by the wayside for good reason.
Now.
And I think a lot of people, right, have expected over the years that the web would go away and be replaced by something else. And yet, interestingly enough, over the last 20 years or so, it seems to keep reasserting itself because the nature of the open nature of the web technologies itself, the web somehow seems to adapt and somehow retain an essence and yet still change. I remember when people felt that the web shouldn't even have images, much less video, for heaven's sake. It should be text-based. And so I don't think it'll be replaced. I think it'll just continue to morph. That's
I think it evolves.
Yeah,
I was trying to find a comparison to that. When you think about, over 100 years ago, the Model T car was invented by a guy named Ford. And at the time it seemed it was definitely would have been considered new technology. And now here we are more than 100 years later, and look how it's completely transformed our society. Can you imagine very many cultures in the world where you cannot survive without a car? Look at how many other subsequent industries have developed because of the need for the cars. You've got the oil industry, you've got road construction, you've got, even the way we lay out our cities now, it's all designed around the fact that we can drive cars. And, it was a transformative technology that has completely influenced the way we move. I think the Internet and the web in general are going to be like that. We may not necessarily call it the web, but the ability to transport information, to link all these different pieces of information together to function in a digital manner will continue to evolve and morph over time.
I think so. And again, it's not just the web, is it? It's the Internet. The Internet is the larger circle.
Yes.
And the web exists within it, right? And so the Internet would include, frankly, all those things I was talking about, but, mobile devices all the way through to your alarm clock. And but interestingly enough, the web will remain the way in which all of that information will be middlewared and transferred to other systems. And I think that's one way in which the web will be very important, not just as a consumer tool, which we all are using right now, frankly, right? Sure. Well, actually, this webcast is the web, but also the Internet, right? But it will be used as a consumer tool, but also as a way in which information as it's processed by users will be brought through the web specifically. Internet information will be brought through the web specifically and then bridged over to fancy systems or legacy mainframe systems to be stored and processed and folded and spindled and mutilated and patterns given to it. That's, to me, clearly where the value, one way in which the value of the web will continue and continue to morph. Yeah, great point. There's a question here from, I think it's Liam, about do you mean the NSA break 128-bit encryption? Yes, yeah, I think the answer is a most definite yes, they do. And there are a lot of countries that don't even allow the use of 128-bit encryption, so that could be broken even more easily. So yeah, they are able to break that. And the other thing that is interesting is using the Tor network. There's an open question as to whether the NSA is able to break that as well. But the Tor network, through more encryption and also through random anonymization and randomization of information, is able to make it a little harder, or maybe even a lot harder for them. So using the Tor network and a few other tools, you can get a higher level of privacy. But those guys at any organization, and people are choosing the NSA. You could talk about MI5 or MI6 or any other organization, well-funded organization. They can grab data pretty well. Well, we're getting near the top of the hour, and thank you very much. I've seen a lot of folks talking about their particular preference. There's one saying, number 3, creating documentation for non-computer savvy users is a way to do it. And I think you do that through crowdsourcing, by the way. That's just my kibitzing there. So great point. And so we have a good interest in all the different, a lot of the different tools here, a lot of the different, ideas. So we will sift through this and come to some conclusions. So if there are no other questions, Lisa, I'll just turn the time over to you and we'll conclude the webinar.
All right. Well, thank you everyone for joining us today. We appreciate your time and hope that you enjoyed today's session and learned a few things. And watch for announcements coming up for when we'll have this posted on our website. Thank you, everyone, and have a great day today.
You bet. Thank you so much, Lisa. Take care, everyone. Thank you all for your time. Bye-bye.